Hello, Assalamualaikum and a very good morning. My name is Hassanal bin Hasan. My metric number BF21103. Okay, we are from Group 3, Section 2. Today, my group will present about the problem drainage system at Taman Universiti Hasan Batu Pahat Johor. D is for subject hydraulic, which is BFC21103. Okay, next, I want to introduce of my group member. The first one is myself, Hassanal bin Hasan. Next, Khairul Hafizie bin Khairuddin. The third is Mohamad Asraf bin Nordin. Then Nur Hidayah binti Azhar. And the last one is Nur Husnina binti Ngisa. Okay, first, I want to talk about introduction. In introduction, I will explain the meaning of hydraulic and the urban stormwater management manual for Malaysia. The study of the mechanical behavior, which is movement or flow of water in physical system, is another definition of the term hydraulic. Hydraulic is the study of how surface or subsurface flow travel from one location to another. There are two types of hydraulic system, which are open-loop hydraulic system and closed-loop hydraulic system. Okay, for the next question is what the urban stormwater management manual for Malaysia? This urban stormwater management manual for Malaysia MSMA second edition is an improved version of the MSMA first edition that provide planning and design guidance to all those involved in the management of stormwater. This manual objective is to offer simple direction to all regulators, planners, and designers involved in the stormwater management implementation, which is frequently carried out by a number of organizations.
Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. My name is Nur Hidayah binti Azhar and my metric number is TF210010. Now I would like to present to you the problem statement of our study. Taman Universiti Private Raja experienced flooding on 4th December 2015, even though this is a not typical location for flooding. The flood destroyed many properties, making life uncomfortable for the community, and it is dangerous for road users as it happens to affect the main road at Private Raja. There are a variety of factors that can cause floods. These floods occurrence cannot be traced solely to natural causes. As we all know, flood causes significant damage to crops, properties, public facilities, and other properties. Therefore, a study is required to discover the exact reason and thereby lessen the impact of floods in the study areas. Next, the chosen study area is at Taman Universiti Private Raja. The yellow outline area in the figure shows that is vulnerable to inundation as a result of a flash flood caused by short and heavy rainfall. This image is taken from Google Earth Pro. Next, these are the images of drainage at Taman Universiti Private Raja captured on 29th December 2020. Next, I will present to you the direction of flow for this case study. The first figure shows the proposed catchment area for this case study at Taman Universiti Private Raja. Meanwhile, the second figure illustrates the water flow direction inside the proposed catchment boundary. The anticipated direction of water flow in Google Earth Pro is governed by the terrain elevation. The current drainage is denoted by the white line, whereas the passage of water over land is denoted by the red arrow. Based on observation in the study area, there are various reasons why this area is prone to flash floods. Heavy rainfall is the most significant factor that causes flooding. Besides, in this study, the issue that causes flash floods in the study area is the need to maintain the existing drainage system, because without the maintenance of the drainage, it will lead to getting clogged with overgrown vegetation and trash. The weeds and overgrown grasses will clog the drainage and prevent the water from flowing smoothly. Next, the formation of sediments at the drainage bottom is a second factor that can make the area susceptible to flash floods. From the observation at the study area, there is erosion from the existing drainage side slopes contributed to the formation of these sediments, which can increase the thickness of sediments at the drainage base. The figure shows sediments collected at the edges of drainage from side slope erosion. Therefore, this can cause the drainage depth to drop, which in turn causes the slopes area to diminish.
Assalamualaikum and hi. I am Mohamad Asraf bin Nordin with my metric number DF2110001 will present to you the methodology of our study. To analyze the stormwater design, there are few steps to be followed. In this study, firstly, the location or area of the study need to be chosen first, with its area less than 200 acres. After choosing the study area, this study need to further estimate the TC or the time of concentration. It means the time it takes for runoff flow to travel from region under consideration downstream to the farthest point in the particular catchment area. Next, the rainfall intensity design need to be determined for the duration in selected frequency. The intensity duration frequency or IDF curves will be used to determine peak discharge. In order to reduce the error, empirical equations can be employed to estimate the value of rainfall. Afterwards, the rational equation model will be configured. It estimates runoff from small drainage systems with significant amount of impervious land. These steps will compute the peak flow of the design. Therefore, this study can design the stormwater to prevent the flash flood. That's all from the methodology.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Hafizie bin Khairuddin, metric number DF210036. So I will continue to present about data analysis. First thing first, we need to calculate time of concentration using this formula. So we need to calculate area, weighted perimeter, hydraulic radius for our existing channel at Taman Universiti, Parit Raja. And we use manning roughness for n value is 0.050 because the channel has tall grass cover above 150 mm at existing channel. Then we need to calculate slope friction using this formula. After that, we need to input all the data into this formula and we get TC about 5 minutes or 0.0834 hours. After that, we need to calculate average rainfall intensity or ARI. First, we need to choose the station that near to the existing channel at Taman Universiti. So we choose store JPS Batu Pahat and we need to input all the constant value into this ARI formula to get average rainfall intensity, which is 357.71 mm per hour. Next, we need to calculate Q peak for our existing channel. For runoff coefficient C value, we choose land use, commercial and business center because our existing channel near to the business center at Taman Universiti. And for ARI, we choose above 10 years because we design for 50 years. For area, we obtain the area by using Google Earth to draw the water catchment area or watershed area at Taman Universiti. So our area is about 10.8 hectare. Then we input all the value into this formula to calculate Q peak for existing channel. Lastly, we need to calculate discharge proposed design. our proposed design is trapezoidal, same as existing channel, but we just adjust the depth of the channel because the area at side is narrow and not suitable to make a bigger channel. So we use Manning coefficient formula, and we need to calculate our proposed design, area, weighted parameter, and hydraulic radius. And then we input the value into this formula to get cubic design for our proposed design. And for final step, we need to compare the discharge between proposed new design and existing channel. Q design must bigger than Q peak to avoid any flood at Taman Universiti, Khairuddin. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Nur Husnina binti Ngisa. My matrix number DF21103, and I will explain about the discussion of our project. It has been proven that excessive permissible development discharge is the major cause of flash flood at the roadside drain along Taman Universiti, Khairuddin. As the dry weather flow combining with the discharge due to the surface runoff, it will result for a higher value of fractional discharge and causing the flooding to be happen. Next, it's due to irregular construction of the earth drain flow channel. The drainage channel is the conduit for water being carried by the earth drain. The channel can continually adjust its channel shape and path as the amount of water passing through the channel changes. The drainage flow velocity depends on shape or cross-section of the channel, irregularities in the channel caused by the resistant rock and stream gradient. Next, the infiltration rate of the soil is one of the additional causes of flooding. Due to the studies, areas are silty clay soil type. It will result in a negative effect where when the rainwater flow through the impervious surface as surface runoff, it will cause an impact on the landscape through the development of watersheds. The occurrence of flood is easier because the flow rate is lower due to the thickness of the silty clay soil layer and subsurface layer. Despite the rainfall intensity or the precipitation rate is low, the area will still be prone to be flooded. From the data analysis to propose the new design channel, the discharge value for this new design is determined after the discharge value of the previous channel or discharge peak is obtained from the previous calculation. The result for discharge peak from the calculation is 10.195 meter cube per second. After calculating the discharge peak value, the discharge value for the new design is determined, which is 17.84 meter cube per second. The discharge value for the new design is greater than the peak design from the previous channel. As this new design exceeds the peak discharge value for the channel, which will be the limit to accommodate the water, it can control the amount of water that flows through the channel. As a result, the new design is still trapezoid in shape, but the channel section, height, top width and bottom width have been changed. Thus, more water can be poured into the drain when a design is made larger as a result of the new design discharge being larger than the previous discharge. Next, the conclusion of our project. Thus, in order to prevent flooding to take place at Taman Universiti, Khairuddin, it's necessary to change the depth of the drainage because the surrounding area is very narrow to increase the width as the place located at the commercial place. By directing water away from the building and toward the surrounding area, this new design avoids water accumulation that could cause flooding. Water that has accumulated can muddy the soil, which can lead to soil erosion. Drainage system controls soil moisture, which prevents soil erosion. In addition, it can eliminate toxic or waste materials by flushing them down the drainage channel's new design with water that is flowing smoothly. There are some suggested flood mitigation methods, which is building a detention pond and connecting it to the drainage system, building a flood wall along both sides of the drainage, and performing proper channelization and dredging work. That's all. Thank you.